Okay, in this video we're going to continue talking about JavaScript and programmatic flow control. And last time we discussed conditionals, and we had if statements, else if, and else, and how those work together and how you could nest them. Now we're going to talk about loops. And there's two primary types of loops, the while loop, and the while loop is the more powerful of the two types of loops. You can do anything with while. For is a type of loop that is sort of a shorthand syntax for a common set of loops we make with while. Alright, so while is the most powerful one. You can do anything you need to with while, but for is sort of a syntactic sugar, they might say. It just makes making a while loop a little bit easier for certain types of while loops. Okay, so let's dig into this. What does this mean? As we discussed before, JavaScript executes a JavaScript file, a JS file, one line at a time, right? So it reads in the actual text in your text file. It tries to determine the syntax, right? And here, these are all comments, so it ignores them. Here it detects that this is an identifier. We see there's a dot afterwards, which means we're accessing a property. So the identifier is holding an object. We're trying to access the property on that object. The property name is log, and that's going to be storing some value. Turns out that's a function, and since that's a function, we're going to use the left parenthesis and the right parenthesis to call it. And then if you have a function, you can pass in data inside the function as an argument. And then finally, at the very end of the line, we have a semicolon. Okay, so that's sort of a lot going on, but we don't really think about that normally when we're coding. But that's sort of what the JavaScript parser, the language engine, sort of has to go through, right? So what we're talking about is trying to change the flow of execution. Usually the flow goes from top to the bottom of the program, and we talked about conditionals where we can say if something is true, then execute another portion of code, and if it's false, don't execute it, or if it's false, execute something else. That's sort of the idea of the if-else. But here with the idea of loops, we're going to continually run something until a condition becomes true. So with an if statement, you run it once if the condition is true. With a loop, you continually run it as long as the condition remains true. All right, so here's a simple example. So while, and then we specify a condition. So while something is true. So this is about as simple of a condition as you can have. This is a while loop, and we have while true, and then we would print console.log. This is infinite. All right, so this is something. This is a bad thing. Normally, the linter's giving me an error. No constant condition. Sometimes in while loops that's appropriate, so we're going to ignore that for now. We run this. This is a bad idea though, because this is going to be an infinite loop, and we'll see that here in just a second. So let me open up, let's clear all this. Let me open up Node, and I'm going to run this new version. This is loops, and we see this is just running and running and running. And up here you'll see this is my processors. I have an 8-core processor. So Node is generally only taking up, it can take up a maximum of 100% of one particular core. Now we see here we're maxing out here, we're getting very, very high, so this is about 100%. This is this process, because it's still executing everything over and over and over again, and we see this process max out. Now we might see it switch to another core after a while if this one gets too hot, and there's some managing that goes on within the computer, but we see one process is maxed out to near 100%. So to stop an infinite loop, you hit Control-C, and that's going to stop the program. All right, that's going to send it the interrupt, send the program the interrupt signal to kill the program. Right, so infinite loops are bad. Right, so what we want instead is sort of something that we can verify will stop. So again, this is just like the if statement. We have some Boolean expression in here that's going to evaluate to true or false. If this expression evaluates to true, we execute this line of code. Then JavaScript checks the expression again. If it's still true, we run the code again. Then it checks the expression. If it's still true, we run again. And it will keep doing this. It loops over and over and over again until one of its attempts to evaluate this expression is false. Okay, so the exit condition is here. Once this becomes false, we exit out of the loop and then continue down here with normal code. So we'll have something like console.log program done. Right? Something like that. So what are we going to have for this expression? So one of the most common things to have for an expression, we'll do something like let, we have some index value. So let I equal 0. And then we're going to say as long as I is less than some ending condition. So let's say that's 10. While I is less than 10, then we're going to print out I. Right? So I is going to start out at 0. And is I less than 10? That's true, so we print out I. But now this block of code is finished. I didn't change, so it's going to go back up here and say, is 0 less than 10? That's true. And it's going to print out 0 again. And then is 0 less than 10? Yes, print 0. So this is still the infinite loop. What we have to do to make sure this is not infinite is increment I. So at some point, I will no longer be less than 10. That's how we can guarantee that this loop will end, right? So we would have something like this, I plus equals 1. So in JavaScript, if you want to increment a variable, you can say I equals whatever I did before plus 1. That's one way to increment. All three of these are the same. You can say I plus equals 1. So this is the same as saying I equals I plus 1. And then the third way is a little bit simpler. You can just say I plus plus, and that increments I by 1. All right, so you'll see all three of these different versions. Most of the time you're going to see I plus plus or I plus equals. Usually people don't do that, but sometimes they do. All right, so all three of these are equivalent. We only need to pick one. All right, and I'm going to show you all three are equivalent. So we might as well start with the most basic and obvious to understand. We're going to change the value of I by setting it equal to something. What are we setting it equal to? Whatever I currently is plus 1. Right? So this loop, at first I is set to 0, and then this Boolean expression is evaluated to either true or false. Is 0 less than 10? Yes. Print out what's held in I, which is 0. Then increment I to 1. Is 1 less than 10? Yes. Print out I, which is 1. Then increment I. So is 2 less than 10? Print out 2, increment. Is 3 less than 10? On and on it goes until eventually we get to, is 9 less than 10? Yes, print out 9, increment. Is 10 less than 10? No, that is a false statement. Okay, so we will not print out 10 here. The last value we'll be printing is 9. All right, so let's take a look at this. Okay, starting the program, and then sure enough we see the first print of 0, 1, 2, 3, 4, 5, 6, all the way to 9, and we do not see 10. Alright, so just to verify that this works with all three of these different ways to increment our variable, let's do this again. Alright, program runs the same way. Let's change it to this. Save it, run it. We see the program runs the same way. Okay, so here we have a concept of a variable we're declaring. We're giving it an initial value. There's a condition. So we might make this, for something smaller if we wanted to. There's a condition. Then there's some code you run in a code block, right? We use the curly braces to designate the code block. As far as node is concerned, the indentation does not matter, but it makes our code easier to read, and so it is very important that you maintain good indentation habits. In a language like Python, it's required. The program won't work the right way if you don't indent properly. And you indent pretty much the same way. Whenever there's a code block, you indent, right? But in JavaScript, you don't technically have to, but it is a good practice, and you won't get hired if you don't indent your code. So it is really, really important. The clarity of your code is incredibly important because you're going to have teammates and even you looking at your own code, things that you've written in the past. If you don't have good habits about how to make your code clean and organized, you'll look at it and be like, what was I thinking? What does this even mean, right? So we have to be very careful about our naming conventions and our coding conventions and that sort of thing. So start your habits now, make sure you indent. All right, so this is a simple while loop, right? So what about, I'm going to add a console.log here that says as much, console.log, and this is going to be our while. Alright, and then I'm going to duplicate this line and move it down. With Atom you can do that with Control D, duplicates a line, Control Z undoes, and then if I want to move a line up and down, I hit Control up and down arrow. Alright, so that's convenient to be able to move around code fast. So here we're going to do a for loop. And so this is the other type of loop. Remember I said while is the most powerful kind. But there's some setup, and you can run into a situation where there's an infinite loop if you're careful. If you're not careful, if you leave off this increment step at the end, right? So you've got the define a variable, a condition, and we have to have this increment step, and then you can put whatever code you want, right? So this is sort of the basic structure, and then this is really your code block, right? But if you don't have these other elements, it might not work the way you think, right? So a for loop is basically a really quick way to define a while loop like this. Right? So for a for loop, we say for, and then we have a variable that we declare, let I equal 0. Right? A lot of times there won't be a space there, just to keep it concise. And then we have a semicolon. Then we have the expression, just like in this while loop, the expression. So here we're going to say, well, I is less than 10. And then another semicolon. And we have one final expression, and this is the increment. So we could say I++, which is probably by far the most common way you're going to see this. But I could also say something like I plus equals 10, right? And I could have this condition go to 100 instead. So this is a valid thing you could do as well. So this is going to increment our loop by, instead of going up by 1 like we did here, I++ increments by 1. I plus equals 10, this is going to increment by 10. So we start out with the variable I, we're going to set I equal to 0. As long as I is less than 100, we're going to do the stuff in this code block, right? Do stuff. So what's the stuff? Well, let's just do the same stuff that we did here, right? The console.log, right? So we're going to console.log I. Now, the difference is this, it's basically the same stuff, right? We have the same declaration. We're declaring a variable I. We have a conditional, just like in the while loop, and then we have something to execute at the very end of the loop, right? And this does execute at the end of the loop. We'll see that here because we know the first time through the loop this is going to be 0, right? So this must execute at the end. If it executed at the beginning, then the very first value would be 10. All right? So this sort of does all of this setup for us in one loop, in one loop definition, right? So we don't have to worry about remembering all of this stuff because it's right here at the top of the loop. And the basic reason for the existence of the for loop is far and away the vast majority of ways you use a while loop is going to be something where you set an index and then set a condition for that index and then increment that index. So even this right here, you're very rarely going to see. It's almost always going to be I++ at the end. But just to show you that you can do something else, we're going to. All right, so this is the for loop. So let's look at this. All right, so here was our while loop. We knocked it down to 4 so it wouldn't take up so much space on our output. And here's our for loop. And we see indeed that the value does start at 0. So this statement executes before any of the loop really executes. It's kind of like having this statement here at the top in the while loop. Then this is the condition we're checking for. So we see if I is less than 100, that's the condition. And then each time the loop executes at the very end, we're going to execute this statement. And in this case, this statement is just adding 10 to I. This statement could be anything. It could be completely unrelated to I, right? I could say 2 plus 2. and then this would be an infinite loop because I'm never incrementing I. So see, I never gets incremented. Now we got this infinite loop happening again, and pretty soon we're going to see a processor spike here. And so we've got some processor spikes going on. So we're gonna stop the infinite loop, right? So these are the two simple kinds of loops, and you'll see them a lot. For loop, you'll actually see less and less of the for loop. Put this down to 40 and put this back to I plus equals 10. Okay, so the one you'll see the most is the while loop. You will see the for loop occasionally, and there's some variations on the for loop which we're going to get into next time. But for the most part, you really don't see the for loop that much in JavaScript either. What we normally do see is iterations, ways to iterate through a list of items. So when you have a list of items, usually it's handy to go through them one at a time. That's sort of what you can do with a for loop. So let's demonstrate that real quick with the concept of a list. So we have a list of items. I'll call this fruits. It's our grocery list, I guess. And we have apples, bananas, and oranges. Right? Three items, and then we're going to make a for loop that iterates over a list. Alright, so we have this list of items, and then we're going to have an index to represent each one of those items. So for let I equal 0, semicolon, while I is less than our fruits list dot length. Dot length is how we get the length of a list, how many items are in that list. So actually I'm using the wrong terminology there, that's Python terminology. This is called an array in JavaScript. So this is how you get the length of the array, but an array is really not that much different than a list in Python. So we have an array, and as long as I, our index, is less than the length of the list. Now this is important because the index starts at 0. Indexing starts at 0. So the index of this item in the list is 0. The index for this item in the list is 1. And the index for this item in the list is 2. Now notice, the length of the list, however, is 3, because there's 3 items. So as long as I is less than 3, then that's a valid index, because 3 would not be a valid index. That would be the 4th item. So remember, the index number of an item is always 1 less than the number of item that it is, right? So this is the first item that's always index 0. The second item is always index 1. Right, so the index is always 1 less, right? So we have, if we have a length of 3, right? If we use the index 3 to reference something in this list, that would actually be the 4th item, and no such thing exists. Okay, so you'll see this form a whole lot. You're going to see let I equal to 0, that's your initialization, and then you're going to see as long as I is less than the length. And then you increment I for the last statement, I++. So this form is one of the most common ways you'll see a for loop used. You have an index that you're trying to pair with the items in a list. And so here you would say item, let item equal, and then our list is fruits. So I'm going to access the item at index I, and then I'll do something like console.log, and let's do string interpolation so we don't forget how to do string interpolation. I'm going to use 2 backticks, and I'm going to say I like $, curly braces, item. Okay, so this is a loop where we iterate over all of the items in a list, and you might do any number of things. We'll change this up in a bit. Let's just run this first, and we'll see what else we can do with these loops. Right, so I run this, And this is our initial while loop, our for loop, and then for each one of these, I've said I like bananas, right? Or I like that item. I like apples, bananas, oranges. All right, so how can we change this up? Let's mix in our conditionals with our loops, okay? So we can say, let's see. Grapes. Grapefruits. And yeah, that should be fine. Let's add one more, I guess. Lemons. Sorry, I'm having trouble thinking of fruits at the moment for some reason. So we've got a longer list now, and let's just run it with the longer list. Not a big deal. It's pretty obvious what will happen for each one of these. We go ahead and say I like, right? But what we're going to do is we're going to add a conditional in here. So maybe we don't like all of these items, right? So maybe we want to check to see the ones that begin with the letter G. For some reason, we don't like fruits that begin with the letter G. All right, so we can have an if statement here. If item, so remember this is our string. This is one of these things, right? Item is going, each time through the list, we're setting a new value to this item variable, and it's just going to be one of these strings. So if item, we can reference the first character of that item using the square bracket syntax. This is referenced by index. So we have a string here, and then square bracket syntax, we're referencing the first item in that string. That first item is the character. So for this first one, that's going to be the character A. For the second one, that's going to be the character B, then O, then G. So what we're going to do is say if that character is equal to the character G. We're going to make our code block just like we would, right? Notice the indentation level. Here we have curly braces. So all of the code inside of this code block is indented, but then we also have another conditional with its code block of its own. So the stuff inside that code block must be indented twice. So we indent once and then twice. Another thing to pay attention to. Here we have an equality comparison. So this is supposed to be a Boolean expression inside of this if statement. So that's either true or false. Notice I've used triple equals. In JavaScript, it's very important that you always use triple equals, don't use a double equals. Okay, we're going to have another video on that to explain that, but that has to do with coercion. If you're not careful, if you use a double equal sign, JavaScript will coerce a value into something that you might not want it to do. Right? So, for example, let's comment that. In JavaScript, something like, I believe this is accurate. Well, let's pull up Node and do that, because that would be a better way to do this. I'm going to run Node, and I'm going to say, is 11 equal to 11? It coerces the value of the numeric 11 to be equal to the string value. That might be okay in some circumstances, but it might not be. So you want to be careful. The double equal sign does not act like most other programming languages. Okay, so this was a good and a bad thing, and eventually people recognize this as being more of a bad thing. So this is considered one of the bad parts of JavaScript, double equals. So they later added the idea of triple equals, which is stricter. And with triple equals, the type has to match as well. So we have something like this. So that is false, whereas with the double equals, it's true. So with triple equals, it won't coerce the type of data and then try to match it up, right? So triple equals is always use triple equals. And so there's also not equal, right? So is 12 not equal to 11? That's true. So this is how you do the triple equals version of not equal. All right, so in this case, is 11 not equal to 11? That is true. Is 11 not equal to 11? Right, and then what if we don't use the triple equals version? Let's see. 11 does not equal. I left off the. Right. So 11 does not equal that, but with triple equals, it's different. Okay. So with the stricter version, 11, the numeric 11 does not equal, or the number 11 does not equal the string 11. Those are two completely different topics. They're two completely different ideas. So this is a much more strict form. So the number 11 does not equal the string 11 with the triple equals form. So that is true. But with the double equals form, 11, the numeric value, the number 11, does not equal the string 11 is false because it converts this to a string. And so it's saying then the string 11 does not equal the string 11, which is a false statement because the string 11 does equal the string 11. Right? So it's a little bit complicated, but the thing you have to remember is just always use triple equals. Or if it's a negated equality, you would do the not operator and then double equals. All right, so that's a quick overview of comparisons in Boolean logic in JavaScript. So triple equals is important. So back to our example here. We're iterating through a list of items. We are comparing the first character of each item, and if it's a G, then those are the only ones we're going to like, apparently. All right, and so let's run this. And so this says we like grapes and grapefruits. It's an odd combination to like. So to change it, to negate this, we would say does not equal. And this is the opposite. So basically all of the items, we liked these because they started with the letter G. Right? But now because we've negated this, this is not equal. So when the item's first letter is not equal to G, now we're going to like it this time. Okay, so that's the power of negating something. So now all the other items we say I like apples, bananas, and oranges, and lemons. Okay, so there's a couple of key takeaways here for this particular one. The for loop, we use it a lot to iterate over items in a list. The I value is the index, and then you get the item from the list by that index each time through the list. Or each time through the loop, I mean. So the other thing is that you can nest programmatic flow statements inside of other programmatic flow statements, right? So this is all about flow control. So I can have one programmatic flow statement, which is this for loop, and it's indented here. Then within that flow control statement, I have another flow control statement called an if. And I could have another loop in here. I could say while I could have another for loop for, and we'll call this let j equal something, while j is less than the length of, let's see, that would be item length. So this is the length of the string item, while j is less than that. J is going to be the index, and we're going to say j++. Now j is something entirely different. It's a different index than I. I is the index going over this list, right? And here we're going to define j to be an index iterating over the individual characters in one of these items. So the first time through the loop, the item is apples. So we're going to have an index 0. J is going to start out at 0, and while j is less than the length of our item, so the number of characters in our item, so the first time that's apples, we're going to go through and console.log item and get the index, the item at index j. Okay, so this is going to print out one letter at a time, the items, or the characters. So this is going to print out, I like apples, then print out A, P, P, L, E, S. Then it'll say, I like bananas, then print out B, A, N, A, one line per letter, that sort of thing. Okay, but the point is we have nested control flow. We have a for loop. Inside of that for loop, we have an if. Inside of that if, we have a for, and we can nest this behavior any number of different ways to accomplish any number of different things. Right? So here we say, I like apples, and we see one character at a time. We're iterating through. I like bananas, and then one letter at a time. Okay, so this is just a basic introduction to loops and programmatic flow control. But the important takeaways is most of the time these types of things are used for iterating through some sort of list, some sort of ordered set of data. Right? That's the primary way these are used. Not always, but the vast majority of the time. Right? And so the next video we're going to talk about iterating through data using different things, different mechanisms. So there's a lot of functions that allow you to iterate through arrays and through objects and that sort of thing. So that'll be next. All right, that's enough for this video.